Okay, I want to pick up where we left off at the end of class yesterday. We were done drawing our picture here. We're done drawing our picture. We're ready to actually solve this. What do we have? Shh. Guys, please refocus. What do we have here? We have a triangle. What information about the triangle do we have?
Side angle side.
Side angle side. We have side angle side. Side angle side is one of those times that we use law of cosines. We want to find L, which is a side or an angle? Side. So L squared is equal to what? How do I use side angle side with law of cosines to find a side? Yep. We're going to take, I'm sorry, what did you say, Carrington? 30 squared plus 50 squared. Close. You're missing just one little piece. 2 times 30 times 50 times the cosine, yes. 2 times 30 times 50 times the cosine of 37 degrees. Hardest piece of this problem is drawing the picture, similar to the quiz you guys took on Monday. And I'll pass those back and we can talk about those at the end. We'll have time. But it's the drawing of the picture that threw most people off. All right. So L squared is equal to 900 plus 2500 minus 3000 cosine 37 degrees. You don't have to do that middle simplifying step. If you just want to type into your calculator 30 squared plus 50 squared minus 2 times 30 times 50 times cosine of 37, that would be fine. So L squared comes out to be about how big? Before we square root it, I want to make sure that we're all on the same page before we hit that square root button. That's after we square root. I want before you square root it. 1004 point something something, right? Yep. 09347 dot dot dot. Now use your answer key, take the square root of that.
31.687.
Do we need units on that, or is that done?
Units, that is miles.
That is in miles. Anytime we've got units in a problem, please make sure that you are putting them on there. If you don't, it does take points off if you're not including your units. Yes, ma'am.
Why couldn't you just use the law of sines?
Why can't we just use law of sines? Good question. So law of sines, I can use an angle and the side across from it, and then angle and a side across from it. I don't have that angle. I'm looking for this side, so I can't set up that proportion.
Right.
And without more information, I don't know how big those two angles are, so I can't find those angles to set up that proportion.
But couldn't you use the 30 miles to find the other angle?
The 30 miles, I don't know how big that angle is, though. So the reason that we have both law of sines and law of cosines is because we can use them in different situations, but there's places where they absolutely don't cross over. When I have side angle side, without more information, there's no way for me to use law of sines. Law of cosines is the only thing that'll work for me. If I had angle side, yes, then I could use law of sines. Because with angle side, I can match this angle and the side across from it, and then this angle, and I could find the side across from it.
So you need at least 2 angles to do the law of sines?
You need at least 2 angles, or if you have side-side angle, that's when we have the ambiguous case show up. But we can use law of sines then as well, as long as it's side-side angle. So here I have side, but then it's not side angle. I have side and then an angle inside. If I had this side, and then this angle, then I could use law of sines. Does that help a little bit? Okay. And we can spend some time after break. We'll have the first 2 days after break to just kind of review what we did beforehand, so we can look at different examples for when would you have to use law of sines, when would you have to use law of cosines, when could you choose between the two. Okay. One thing I definitely wanted to point out about units, please, please, please make sure you're putting units on your answers where units are possible, especially if you're finding an angle. Because if you're finding an angle, if it's in degrees, what should it have? It needs to have that little circle next to it. If you don't put the circle next to it, it's still an angle. You're just telling me that it's in what units without the circle? Radians. And there's a big, big difference between radians and degrees. So if it's in degrees, you've got to put the little circle there. Did you have a question for me, Hanani?
Oh, I was going to ask, during the test, will you distinctly say use law of cosines to find this, or?
Nope. And that's why we'll spend some time after break talking about how you know when to use each of those. So that's a great question. This is the last story problem I've got for you guys, and then we're going to talk about some applications for area that come from law of cosines. All right, so Caroline is running at a constant speed of 1 mile every 8 minutes, and she's running in the direction south 40 degrees east for 20 minutes. Then she turns in the direction of north 20 degrees east for 16 minutes. That's a lot of information all at once. Brendan, you with me? All right, please put it up. So I'm going to start with her starting position. From wherever her starting position is she going to go north-ish or south-ish from there? South-ish. So I'm going to put my dot higher up on the paper. So here's the starting position. And then because they gave me bearings, I'm going to draw a tiny little compass rose in the background. So here's south, here's east, here's west. From where she starts at, you said she heads south-ish from there, so I know I'm facing this way. And then am I going to go left or right from there? Right, because it says south 40 degrees east. So I want to go towards the east, which is towards the right on my compass rose. So I've got something like this. And where do I put the degree markings? Where do I put the 40 degrees? Yeah, from south over to that line that she actually ran on. Here's my 40 degrees. So far, so good? Just chunking it out one piece at a time. She did that for how long? For 20 minutes. And we know she's going how fast? So 1 mile every 8 minutes. She does that for 20 minutes. So how far has she gone? How far? 2.5 miles. So I'm going to write that in over here. 2.5 miles. We've made sense of the first sentence now, right? Now let's look at the second sentence. She gets to this point right here, and for whatever reason, she decided to turn. So I'm going to need another compass rose because they give me another bearing from this place right here where she's turning. So I'm going to draw another little compass rose here. I've got north, south, east, and west. Is she going, because again, I always have to decide up or down first when they give me a bearing. Are we going north-ish or south-ish from here? North-ish, okay. So this way. And then am I going left or right from here? To the right, because it says northeast. So we're going to tip off to the right. Something like this. I don't know. I just need a triangle here. Where do I put the 20 degrees that they gave me to work with? Yes. So this whole space? Just from the north over to there. This is what's 20 degrees. And it doesn't give us any other information, so this must be where she stops at. How far did she go after she turned? How do you know? 1 mile every 8 minutes. She did this for 16 minutes, so 2 miles. So far, so good on our picture? Are those bearings making like somewhat sense? Because right now I'll settle for, I still struggle to do it on my own, but when you draw it, I can make sense of it. Or I can tell you what to do and it makes sense. Like if we've gotten there on the bearings, I feel like we've made huge leaps and bounds from where we first started with bearings. What do they want us to find out here? Distance from the start to the end. So we're looking for this. I'm going to call it D for distance. I almost have side angle side, right? To use side angle side, what would I need? I need that bottom angle. I have part of this angle. I've got that 20 degrees there. How big is this part right here? Because if I know how big this part is, then I know how big the whole thing is. This whole thing right here is 90? On the way I drew my picture, it looks like it could be 90, but I don't trust my drawing. Why? Why? So here's what I'm looking at. When you look at a compass rose, that's just like our 4 quadrants on a graph, right? I know that top angle is 40 degrees. If I pull down my bearing and I make a right triangle out of it, how big would this be right here? That would have to be 50 degrees, right? Why? Yeah, my triangle has to add up to 180. I know that this is 40, and because this is a north-south line, I know if it meets with an east-west line, it's going to make a 90-degree angle. So 90 and 40, I need it to be 180, so that would have to be 50. So how big is this part right here? 40. Because again, together those are making a right angle. Find my blue here. So this is 40 degrees. So this angle in between my two sides is how big? 60. Do I have enough information to use law of cosines? Yes, because what do we have? Yes. We have side angle side. We decide how to name it because as I'm walking around the triangle, like, I don't know this, I don't know this, I know this side, And then I know this angle, so it's side, angle, and then side. Yes, Ibrahim?
Could we use alternate interior angles to find that?
Yeah. Alternate interior angles works on this exact same philosophy because any east-west line, those are going to be parallel, and then the path that she ran would be the transversal that cuts it. Yes. Alternate interior angles is absolutely a perfect application here. All right, so I want to find D. So distance squared would be equal to what? 2.5 squared plus 2 squared minus 2 times 2.5 times 2. Anything else? Times cos of 60. Yes, ma'am.
Didn't you say for side angle side we can use law of sines?
Side angle side, you cannot do law of sines. You can do it for angle side or angle side angle, but not for side angle side. All right, so now we're going to simplify this. Yes, ma'am.
If you find another angle, you can use sines.
Yes, if you can find another angle, then you could do law of sines. Yes.
And we can't.
Can we? Which angle could we find?
We can find 50 the other side and the top. And
This one here?
yeah.
Only if it was directly to the east. It's not directly in line. If it was, then I would have a 90 degree and I could subtract. It's off just a little bit, and I don't know how much that little bit is. But yeah, I looked at that exact same thing. I was like, oh, we can just, no. All right, so I square the 2.5. That'd be 6.25 plus 4 minus, let's see, 2 times 2.5, that's 5 times 2, so that's 10 times the cosine of 60. Do I actually need my calculator for this? Cosine 60 is what? 1/2. So I have D squared is equal to 6.25 plus 4 minus 10 times 1/2. I'm going to need my calculator at the end to do the square rooting. But in the meantime, I have D squared equals 10.25 minus 5, right? So D squared is equal to 5.25. Now I need to square root it. What is the square root of 5.25? You said 2 point what? 2.29. Do we have a third decimal point? 1. Do we need units? Miles. Always check to see if there are units, and if there are, you need them. All right, we're going to switch gears just a little bit. We're going to talk about area now. How do you find the area of a triangle?
Ms. Bill, last question, I'm sorry.
No, you're fine.
So if you were to, since you have the distance, if you were to do the other formula to find an angle, would it equal 60?
To find which angle?
The A squared plus C squared minus B squared.
What angle are you looking for? That's my question.
No, we have it, but I'm saying the 60-degree angle at the bottom across would be.
Right here?
If you were to use that equation, the A squared plus C squared minus B squared, over 2A, would it equal 60?
If you were to use this side right here that we now have,
Yeah.
yes, it should give you a 60-degree angle down here, so you could use that to double check.
Okay.
Absolutely. Because we had to round on our square root, it's probably not going to come out to be precisely 60 on your calculator. If we hadn't needed to round, then it would. but because of rounding error, it would come out as like 59.9998743 something. All right. So what did you guys tell me the area formula was for a triangle? 1/2 base times height. Here's a new one. We're going to talk about y. This formula here, 1/2 a times b times sine gamma. Assume that I have given you values for a, b, and gamma. So assume we have a, b, and gamma. I'm going to draw a triangle. And I'm going to label it, so here's A, B, and C. So gamma's up here, and that's an angle that you have from your given information. Side A would be here, side B would be over here. So this is side angle side, right? We have side angle side. What's the base of the triangle with the way I've got it written? Yes, and I'm sorry, I labeled my triangle wrong. We gotta move our letters around, sorry. I want C over here. Sorry, my bad. I'm thinking about the way I had myself oriented on the triangle, and I don't want to mess up what I'm saying. Technically, it doesn't matter how we have it set up. But I'm thinking about it one way in my brain, and I want to make sure I explain it clearly. So side A is down here, and this is side C on the other side. We still have side angle side, though, right? The base of this triangle is this, right? Here's our base. So if I'm thinking 1/2 base times height, what could I sub in the place of where it says base? A. So my base is A. The 1/2 is already repeated right here, right? I still need the height of this triangle. Where's the height in my picture, or how would I find the height? Drop an altitude from angle A down to side A. And what's a feature of altitudes that we're making use of here? 90 degrees. So that's my height. Can you see any way that I could use the given information, A, B, gamma, to find the height? What could I do? I can use sine. Sine of gamma is equal to opposite over hypotenuse, right? What's the opposite of gamma? If I'm looking at the 90 degree, I'm just looking at this little triangle that we've made. That's H over the hypotenuse, which would be B, my base. So here's the opposite side. Here's the hypotenuse. How do I isolate that for the height? Times B on both sides. So the height is equal to B times the sine of gamma. This right here is my height. So this is working because of the same area formula you know for triangles already. This works when I have side angle side. 1/2 multiply my sides together, times sine of the angle that's in between them. And I can find the area of this whole triangle. All right. Let's do a couple examples using this. They're very fast. Once we have them set up, we're going to pop them in our calculators and get our final answer. Find the area of a triangle if gamma is 143 degrees, A is 7 meters, and B is 18 meters. Do I have side angle side? Yes. So my area is equal to 1/2 times what? Times 7. And that's 7 meters times what? Times 18 meters times sine of 143. Pop that in your calculators and tell me what you get. What's our area? How much? 0.914. Remember, always take it out to 3 places for me, unless that is not possible. Do we need units on this? Meters squared, because remember we had meters times meters, so that's going to be a meters squared. So far, so good? Let's do another one like this. Find the area of 2 sides of a triangle measuring 30 feet and 48 feet, have an included angle of 40 degrees. Do I have side angle side? Yes. What word tipped you off that it was side angle side? Included. That means in between them. So area equals 1/2 times what? 30 feet times 48 feet times sine of 40 degrees. Pop it in your calculator. What'd we get? 462. Give me the decimals. I want 3 after the dot. 807. Do we need units? Feet squared. One more problem and we'll call it a day. Are these easier? Good. Knowing when to use it is really important. Side angle side. So even though we're using sine instead of cosine, side angle side is what we're looking for here. Same thing that I need when I'm using law of cosines. In triangle PIG, time to draw a triangle. Totally not to scale. What information can I fill in on this triangle? Angle I is 40 degrees. What else do I have? Side length of I is 4 inches. What else do we have? Angle G is 81. Side G is 12 inches. Do I have side angle side? I can get it. So let's get it. How do I get the angle in between? Subtract from 180. So I'm going to subtract 81 degrees, and I'm going to subtract 40 degrees. And we get what? 59 degrees. Now do I have side angle side? So now I can use that area formula. Area is equal to 1/2 times 4 inches times 12 inches times cosine? Sine of 59 degrees. You get that it's about how big? 20.572 inches squared. I was wanting to pass back your quizzes today, but we've got 2 minutes until the bell because our lovely shortened periods. However, tomorrow I only have 3 example problems for you, and they're only slightly longer than these last 3 that we did here. So that will not take the whole class period. I'll pass back your 8-1 quizzes so you can see how you did, and we'll talk about that picture. For those of you that are wanting to kind of look ahead a little bit, what we're looking at tomorrow is called Heron's formula. I'm not going to do a proof of why this formula exists. It's in your book. But the proof for why it is the way it is really, really lengthy and kind of hard to follow, at least in the class time that we have. So I'll introduce the formula. We'll practice using it. If you want to see the proof of why it is the way it is, I'll give you the page number in your book, and you're welcome to walk through it, or I can walk through it with you if you like. All right?